So now let's look at how to multiply matrices together. So matrix multiplication, it turns out, is based on the definition of the dot product. So the dot product of two vectors x and y that have the same length is defined to be, well, it's denoted by x dot y. And the way it's defined is you take the first entries of each vector and multiply them together, and then the second entries of each vector and multiply them together, and and so on and so forth. And then you add up all these products together. So it's the sum from 1 to n of the ith entry of one times the ith entry of the other. So you just pair them up, multiply together, and then add everything up. Okay, and so then the way this works is that if we have a times b and we call the product c, then this thing has the ijth entry of the product is going to be given by the ith row of A dotted with the jth column of B. So suppose we have A is 0, 2, 1, 0, and B is given by 2, 4, 0, minus 1, 0, 2. Okay, then A times B, 0, 2, 1, 0, times 2, 4, 0, minus 1, 0, 2, is going to be given by, and so let's see, so we will look for the first row, first column, right? So this is C11 right here. So the recipe is we take the first row of A and the first column of B, and we take their dot product. And so let me make a little room here. That's going to be 0 times 2 plus 2 times negative 1. So that's all going to be the first 1, 1 entry in the product. If I go on to find the next entry, the one that goes right here, this is going to be C12. So I'm still looking for, so the C1 means first row of A, and C12, the 2 means the second column of B, so that's here. So I take the dot product of the two blue vectors, and I have 0 times 4 plus 2 times 0. And then for the next one, I'm looking at C13, so it's going to be first row of A times third column over here, so I have 0 times 0 plus 2 times 2 as my dot product. And then continuing along, now for the next one, I'm going to be moving downstairs and looking at what's going on here. So this is C21. So that 2 now indicates that I'm looking at the second row of A, and I'll be taking the first column of B since it's 2, 1. And so I have the 1 times 2 plus 0 times minus 1. And for the next one here, I will have the first row, second column. So that will be 1 times 4 plus 0 times 0. And do I have any colors I have not used yet? Here we'll go how about lilac? There we go. So then I'm going to have 1, 0 times 0, 2. All right. And so then that's going to be 1 times 0 plus 0 times 2. Okay. And so that gives me all of the entries. Now I've written it out this long way here. When you actually do it in practice, it'll go much, much quicker because you'll probably skip these intervening steps and just figure out, okay, so this is -2, and then that one's, next one's 0, and then the next one's 0 plus 4. Coming across the bottom then, we have 2 and 4 and 0. Okay, so that's how you multiply two matrices together. So sometimes this is written as entry-wise as saying that this is the sum from k equals 1 to whatever the length of the vectors are of a I k b k j. And so the idea here is that in the first one, k is ticking through the columns. So you're as you sum from, as k changes from 1 to n, you move through columns, and that means that you're moving horizontally. In the other term here, k is the row index, and this means you're moving through the rows. And so if the row index is increasing, then that means you are going down. Okay. And so let's also look, what would happen if we went to multiply b times a? Well, if we went to multiply b times a, we would have 2, 4, 0, -1, 0, 2 multiplied against 0, 2, 1, 0. And then you have a problem, because this row vector, because you always take the row from the first and the column from the second. So this row times this column, undefined. We cannot take the dot product of two vectors that are not the same length. So this is just nonsense. So here we've come across one of the first big departures or differences between matrix multiplication and multiplication for regular numbers, and that is that the order matters. So AB is not the same as B times A. And this is a little crazy, and we'll see that it has some interesting implications actually for that you wouldn't necessarily expect. We say that matrix multiplication is not commutative. Not commutative. So that's the failure of matrix arithmetic in this one regard.